Hello, first grade Cougars. We are going to start our engineering project, and I'm very excited about it. It's one of my favorite engineering projects that we do at Carpenter. And in order to get started and to learn about it, we're going to start by reading this book called Paolo's Parachute Mission. And normally I would read this book, but it's kind of a long book. So instead of reading the book to you, I'm going to just kind of tell you a little bit about the story about Paolo's Parachute Mission. And this is part of the Engineering is Elementary curriculum. And I really like it because it helps you understand how engineering helps people solve problems. Okay, so it's about a boy named Paolo, and he lives in Brazil, in a big city in Brazil. But he had to move to a small village. So here he is, he's unpacking from his move, and he moved because both of his parents are aerospace engineers. An engineer is a person who designs technologies to solve problems. So they are aerospace engineers. They are engineers who solve problems about going into space, things like that. So they had to move to a small village where they were going to be working with the Space Agency of Brazil and helping to design different spacecraft. Well, Paolo did not want to move. I don't know if any of you guys have ever had to move, but sometimes you don't want to do that. It's a little hard to go to a new place. I wanted to show you a little bit a map of Brazil. So Brazil is in South America, and it's down over here. And I'm going to show you on the globe. So again, here's the globe. This is a model of the Earth, and it is a sphere, right? It's a ball, it's a sphere. And the word hemisphere means half of a sphere. So the equator cuts the globe in half, and we have a northern hemisphere, half of a sphere, and a southern hemisphere, half of a sphere. Now, the United States is the northern hemisphere, and here we are, the North America. And if you look down here, there's Central America and then South America. So South America is in the southern hemisphere, and this is Brazil, and it's covered with an enormous rainforest. So it's a very green, lush area in Brazil. Okay, so they moved from a city in Brazil to the countryside in Brazil because that's where the parents are going to be working with the space agency, okay? So one of the reasons, and there you can see the parents are talking about being aerospace engineers and helping to design the materials, the space facilities so that they can go into space. Not they could go into space, they're the engineers, they're not the astronauts. So one of the reasons that Paolo did not want to move to this new area is because Paolo is a little different. Paolo was born with just 3 fingers on his right hand. And so he is self-conscious. He's worried that people who meet him will make fun of him because he only has 3 fingers on his right hand. So he doesn't really want to meet any new people. He doesn't want them to stare at his hand and make him feel uncomfortable. But he has plenty of friends right now. He doesn't want any new friends. But when he was unpacking, he found his soccer ball, and he likes to play soccer. And he also found a parachute. And he had been playing with this parachute when he lived in his city in Brazil. And he used to play with it and try testing different things. And so he thought that might be fun to kind of play with his parachute, and he met a boy named Lucas. Lucas was a neighbor boy who loved to play soccer, just like Paolo, and he wanted to go into the rainforest and pick a special kind of fruit, and it's called a capuacu. a kapuaku. And a kapuaku is a special kind of fruit that's very sweet and it's delicious and it's big and it grows on a tall tree. So Lucas was inviting Paolo to go with him to go pick some of these fruits. All right. The problem with picking the fruits was that you have to climb up the tree very high, and the fruit is very big and heavy. And how were they going to get the fruit down? Well, they tried just dropping the fruit to the person on the ground, but it was so heavy, it fell and cracked open. So now they had to figure out a way to get the fruit down from the tree without cracking. Well, Paolo thought to himself, we can use a parachute. So he started explaining to Lucas what a parachute was and what the parachute could do. Lucas was very excited and he said, yes, let's design a parachute. So they started coming up with a plan. And one of the things that they did in the plan was that they first asked a question. Okay, how big is the fruit? How do we want it to get down to the ground? What can we do? They imagined some solutions. They made a plan, they built it, and they tested it. And this is a picture of the boys working together to test some of their designs. And at the end, they became good friends and they worked together to design and build a parachute so that they could drop fruit from a tall tree onto the ground and it wouldn't get cracked and broken. So, boys and girls, this is just a kind of an inspiration for us as we start designing and learning about parachutes. So let's take a look at the parts of a parachute and also how a parachute works. So there are three parts of the parachute. There's the canopy, which is this part area up here. There are these strings or lines, and then there is the load, okay? And this is the thing that we want to drop. So in our story, these were the fruits that they wanted to drop from the trees, right? So how does a canopy work? Well, remember, things fall to the earth because of gravity, right? Gravity is a pulling force. Gravity pulls things down to the surface of the earth. So gravity is pulling down. Now, as the parachute drops down, it's actually traveling through something. It's traveling through the air. And the air gets trapped underneath the canopy and it pushes back up. And it creates something called air resistance. Air resistance. And that air resistance is a pushing force. Remember we talked about pushing and pulling in kindergarten? Gravity is a pulling force and air resistance is a pushing force. So the parachute falls down because gravity is pulling down, but it falls down slower because the air is trapped underneath the canopy and offers air resistance. It's pushing back up. Now, what we want to do is we want to find out how to design the best parachute to fall slowly. So now we need to take a look at how we can test the different parts of the parachute and design a parachute. All right, let's get started. Okay, so let's take a look at the parts of a parachute. So when we make a parachute, or when we design and build a parachute, there are three parts to the parachute. There's the canopy, which is like a big piece of cloth or plastic or something that's going to catch the wind or the air. There's the string, and there's the load. Now, if we want to test how to make the best canopy, we need to evaluate and change different things to find out what is the best design, right? So I think that there's some things that we should test. We should test the size of the canopy. We should test the length of the string. And we should test the type of material for the canopy. So let's take a look over here. On the canopy up here, I think we should test a large canopy, a medium size canopy, and a small canopy. And we're going to see which one is better, which one falls the slowest. Then the strings. I think we should start with some long strings, some medium strings, and some short strings. And we're going to test which one makes the parachute fall the slowest. Okay, and then lastly, I think we can take a look at what is the parachute made out of. We could make the canopy out of a coffee filter, we could make it out of plastic, like a plastic bag, and we can make it out of cloth. So we're going to test those things. We're going to test the size of the canopy. We're going to test the length of the strings, and we're going to test the type of material for the canopy. And when we do that, we're going to gather some information, some data, because we're scientists. We're going to gather some data, and then we're going to decide what we should use to design our parachute.